Solving basic kinematics questions isn't tough. It helps to be organized, but there are some caveats. Kinematics questions for us, are going to be questions that involve, for the most part, a constant acceleration. In a couple days, we'll talk about situations in which we don't have a constant acceleration. But for the time being, we're going to deal with just constant acceleration. If you have a constant acceleration, that means your velocity versus time graph is constant or linear. And that sets up, like we talked about last time, the idea that you're going to have a starting velocity, a final velocity, a change in position, an acceleration, and time. This represents the 5 motion variables. And although we've defined them before, it's important that we take a minute to remember displacement, initial velocity, final velocity, acceleration, and time. 4 of these are vectors, and therefore their direction matters. And it's kind of easy to pick them out because they're going to have units in the problem, and deciding what you've been given is usually the first step in figuring out where to go. So in any one of your problems, you could probably sort out what you've been given. Now, at the same time, when we talked last, we created a set of equations from looking at our velocity versus time graph. And those equations were things like v equals at plus v naught. And this has got 4 of the motion variables in it, but it's missing displacement. In fact, we can go down this list, and for every variable I've listed, there's a Galileo's motion equation that has everything in it except for the 1. So if we keep going down the list, there we go. And lastly, oops, I don't want to write it like that. I want to write it like this. Five motion variables, 5 motion equations. Each equation has 4 things in it. So if you understand algebra, you know that to use these, you need to be given 3 pieces of information in any one problem. So let's consider a straightforward problem and how you might be able to solve it by just kind of an algorithm. Okay, so let's consider. A car slows from 20 meters per second to 10 meters per second in 45 meters. How long did it take? All right, so the first thing I want you to consider is that we know there's going to be a motion problem when they start talking about a change in velocity or give you a distance or a displacement or a time. I mean, it's kind of clear from the problem that we're dealing with kinematics information. Now, your job is to take and sort this into your 5 places. And I think it's pretty obvious what goes where. Because like I said before, I have something in meters per second. I have something in meters. All of our motion variables have units. So let's just kind of throw in all the things we know. Car slows from 20, so from 20 suggests that's where it started, to 10 meters per second. That sounds like where it ended. So initial and final. In 45 meters. That seems like a displacement. How long did it take? So I always suggest putting the question mark. That'll help you out. Now, we need to figure out the most efficient way to solve this. And the most efficient way is to find the one relationship that has everything in it that is listed here and our question mark one. Now, we weren't given the acceleration. So what I did is I wrote all the motion variables out. And by writing them all out, what I've done is I've organized them. For example, this is the one that has all 4 motion variables in it, except for this one. By writing it this way, I will point out I wasn't given the acceleration. So I can't use it to solve for my answer. But that also suggests that this relationship, which doesn't have acceleration in it, so that relationship has the 4 motion variables involved in the problem and has left out the one that we don't have and don't need. So I'm going to grab that relationship and know right from the beginning it is likely going to be something that I can use to solve for my answer. So we wanted how long it took. Put my 45 equals 1/2 10 plus 20 times t. All right, well, let's see if we can do this. 10 plus 20 is 30. Half of 30 is 15, so I get 45 equals 15t. So t must equal 45 divided by 15 is 3 seconds. There's my answer. Not hard. Now, this is a very basic exercise. So your problems can get more difficult, obviously. I try to just show you a simple way that you can start, a place where you can get things rolling and then see if there's enough information to make a solution. Your problems are going to get harder, and there's a couple of caveats on the way this works. Caveat number 1, this whole thing only works for one acceleration at a time. Second, it's for one object at a time. So if you have more than one object, you need 2 sets of motion variables. If you have more than one acceleration, you'll need 2 sets of motion variables. A set of motion variables for each object and each acceleration. And that's not a particularly complicated question. Consider maybe you want to find out how long it takes a car to speed up to a certain speed and then come back to stop. Well, that would probably be 2 different accelerations. The acceleration while speeding up and the acceleration while slowing down. 2 sets of motion variables. Or maybe you have 2 cars that are competing in a race, and you're trying to see which one gets to a certain displacement first, or you're trying to see, some comparison between the 2 of them. You'll need 2 sets of motion variables, 1 for each object. And one final caveat. Don't forget, there are problems classified as free-fall problems. Free-fall problems are problems in which gravity provides the acceleration. On these problems, gravity is going to be your acceleration. So for these, use g, which is 10 meters per second squared, or 9.8 meters per second squared.